Okay, hi guys. We are nearing the end of Math 171, which I'm sure that's good news for you guys. So we're looking here. We've two sections left, this one and one more. So hopefully I can get these videos knocked out. This will actually be the third time I'm attempting this particular video, so hopefully third time's a charm. Okay, so here in section 5.5, we're looking at solving exponential and logarithmic equations. You'll see me use techniques, many of the techniques that I use in this particular video for solving these equations are utilizing the properties that we've discussed leading up to this particular section. So those properties where we were expanding and condensing logarithms in the previous section, where recognizing that logarithms that were commonly base 10 and natural log is base e, we'll use those. And then we'll also use this property that you see up here at the top, that when you have the bases, same base raised to different powers, then it's legal to drop those bases and let the powers equal one another. A new technique you'll see in this one, and you'll see it on the next page, when you have the log on both sides with the same base, it has to be the same base, then it's legal to drop the logarithms and set the arguments equal to one another. So those will be a couple of new techniques, and then there will be still yet a couple of others. I'll be doing the majority of this set of notes. There'll be just probably about 3 or 4 problems that I skip. So with that said, if there's ever at any point where you feel like, hey, I need to try that before she talks you through it, I talk you through it, then by all means pause the video and try it. And then of course you've got the fully worked out solution key available to you online in Blackboard. All right, so let's go ahead and get started. You'll see here on the front page that I use majority of the techniques going from logarithmic to exponential form. But and then sometimes, you know, I'm in a couple of them, I actually, or at least one of them, I'm going to do it a different way than I did it on the solution key, just to show you that there's more than one way to do it. And if you say, well, hey, why didn't she do it that way? It's just maybe just because I didn't think to do it that way, or, you know, one way is just as easy as another, that sort of thing. So as long as you get the same final answer, you're probably tracking and doing okay. All right, so looking here at number 2, I'm sorry, letter A, I got the base down there, was getting me off, is all these problems just say use properties of log to solve each equation without a calculator. So in part A here, I'm just going to go from logarithmic to exponential form to solve this for the x here. So remember that's base raised to the right-hand side, so 2 to the x equals the argument 16. Some of you might right here just say, oh, I know what the answer is. And if you do, then great, go with it. Another technique, though, is we could say, okay, well, how could I write 16 as 2 to a power? Well, 16 is the same as 2 to the, fourth power. So again, now we see, okay, I've got the same base. I can drop those, set the exponents equal to each other, and I'm already solved. Final answer. All right, let's scoot on over here to part B, solving for x. So going to, from logarithmic to exponential form, base raised to the opposite side, so x squared equals the argument 49. To get x all by itself, take the square root. Square root of x squared, it's just x. Square root of 49 would give you plus or minus 7. But remember from our previous video or previous section that your base can never be negative, so your only answer here is a positive 7. Bases are always positive. All right, move on down to letter C here. Base 25 raised to the opposite side, which is x, equals argument, which is 5. I'm going to try to get both of these to have the same base, so I've got 5 to the first power on the right-hand side. I could rewrite 25 as 5 to the second power, so I would have 5 to the 2x equals 5 to the first. Same base, drop them, and then I would have 2x equals 1, divide by 2, so x equals 1/2. If you go back and look at this first statement here, 25 to the 1/2 power, remember, the 1/2 power is the same as taking the square root, and sure enough, the square root of 25 is 5. Okay, so x equals 1/2 is our answer there. Moving over to letter D, going from logarithmic to exponential form, so 9 raised to the negative 2 equals x. We saw in the previous section 5.3 and 5.4 notes at the top, I gave you a recap of exponent rules. Remember, if you have a negative exponent up top, it's legal to move it down to the bottom, and that makes it positive. Or if it's negative on the bottom, you can move it to the top, and that would make it positive. And then 1 over 9 squared can just be reduced to 1 over 81. Final answer. Let us do letter E. This is the one where I'm gonna do it differently than I did it on the solution key, so you can see it worked out differently on the solution key. I'm still going to go, I'm going to use the same technique that you've been seeing me do here. I'm going to take my base, raise it to the opposite side, equals the exponent, or the argument, excuse me, the argument 36. Now if I can get the 36 over here as raised to a 6 to a power, which I can, 36 is the same as 6 squared, and this is 6 to the 5x plus 3. Now at that point, I have the same base, I can drop them and set those exponents equal to each other. And then from here solve for x. So at this point, now we're at the same spot as far as if you're looking at the solution key and looking at how I did it there. So then I subtract 3, 5x equals -1, divide by 5, so x equals -1/5, final answer. All right, in letter F, there's just a stray number 2 there, so you can just ignore that. In this one, you already have a natural log sitting there. Remember from a previous set of notes that natural log is naturally base e, and so whenever that base and the argument behind it match up, then it will condense down to just being whatever is in the exponent. So -2x equals 8. Solve for x, divide by -2, so x equals -4. Final answer. I'm going to let you do G and H because those are very similar to things that I've already been showing. I'm just going to look on down here at letter I. In letter I, I'm trying to solve for this variable x, but it's in the exponent. So in order to get rid of get it out of the exponent, remember since it's base e, take the natural log of both sides. Whatever you do to one side, do to the other. On the left-hand side, just like from that previous problem I just did, natural log is base e, so those are matching up. So I just have -2x plus 1 then equals the natural log of 13. And now your goal is to solve for x, so subtract 1. So then -2x equals the natural log of 13 minus 1. You might want to put a parenthesis there just so you remind yourself you're only taking the natural log of 13. Okay, and then lastly, divide by -2. So exact answer then would be x equals the natural log of 13 minus 1, all divided by -2. And then as far as typing this in your calculator, you could just do it step by step. You could take natural log of 13, hit enter, then do -1, hit enter, and then divide by -2. That is approximately a -0.782. If you wanted to type it all in your calculator at one time, you would need to put in a parenthesis up top like so. You would need to type it in exactly how you see it here. So that gives you an exact and an approximate answer. So far in solving these little equations here, you've seen me just basically utilizing properties that that I've introduced to you in the previous section, in section 5.3 and 5.4. However, there are some problems that we'll have to step it up a notch. We'll still be using our properties of logs where we were condensing and expanding our logarithms. We'll take the log of both sides. But one key thing that you do need to note here, let me highlight this for you, is that when you are solving logarithmic equations, it's important that you check your solutions, because remember, you can only take the log of positive values. So what that means is once we solve for x, let me come back up here if I've got one. Yeah. So like in letter G, once you solve for x, you just need to make sure that this piece right here stays positive, that the 3x minus 2 stays positive. And so, like for example, if you were to put in a +1 there for x, oh, okay, well that argument there stays positive. But if your x value, let's say, was a -1, then that would be -3 minus 2. Then I would then be trying to take the log of -5, and I can't take the log of a negative value. So with that said, though, just because a number is negative does not necessarily mean it can't be an answer, and just because a number is positive doesn't mean that it will be an answer. So it's just what needs to happen is you need to make sure that what you're taking the log of, the argument, this part right here, that needs to stay positive. Okay. All right, so let's flip it over. Of course, you'll have an example over here to kind of illustrate what I'm talking about there, more in hard terms. Okay. All right, so flipping on over to the next page, we're solving our equations here. You'll notice here in number 1, I can't just simply, I can't take a number and raise it to a power and get 6, nor can I take any number and raise it to a power and get 21. Not a nice whole number anyway. So because of that, I won't be able to use that technique that we were using on the previous side. But what I can do is I can take the log of both sides, because logarithms allow you to solve for variables. Oops, let me erase that. Logarithms allow you to solve for variables that are in the exponent. On the solution key, I used the common log. So here on this video, I'll use natural log just so that you can see you can use either one. The only time you have to use natural log, though, is whenever you see the e. When you see the e, you need to be using natural log. But otherwise, you can use common log or natural log. Okay. All right, so here in number 1, if I want to solve for x, then I'm going to take the natural log of both sides. And like I said, my solution key shows that I used common log so that you can see it both ways. So if I take the log of both sides, natural log of both sides, then it would look like this. Natural log of 6 to the x equals natural log of 21. So now from here, remember that when you take that natural log, it tells me, or log, it tells me that the exponent up here can come down in front as a coefficient. So I have x natural log of 6 equals natural log of 21. To get x all by itself, divide by the natural log of 6. Cancels out. So x equals, you would put in your calculator, the natural log of 21 divided by the natural log of 6. Again, it's either put it all in your calculator at one time, just be careful with your parentheses, or just type in the top, hit enter, divided by, type in the bottom. But this would be the same as typing in the log of 21 divided by the log of 6. These two answers here would be consider your exact answers, and then approximately, either way you do it, you're going to get 1.70. Okay, so I've given you the exact form as well as the approximate form. All right, so here in number 2, you have e raised to a power. So just like we did on the previous page, to get rid of that e, take the natural log of both sides. Whatever you do to one side, do to the other. But the nice thing is then on the left-hand side, natural log is base e, so the e and in that argument match up. So that's just going to collapse down and give me what I have left over in the exponent. So 0.03x equals the natural log of 251. And then divide by 0.03. And so x equals, that would be my exact answer, natural log of 251 divided by 0.03, which is approximately 184.18. Okay, and then you can check yourself by going back up here to the original problem. You can say e raised to the 0.03 times 184.18. You're going to get really close to 251. You won't get it exactly because we have done some rounding, but you should get really close to it. That's a way to check yourself. Okay, we move over to number 3. You notice here that you've got log of an argument equals log of an argument. So if we look back on that front page, this is where I'm going to be using this technique, right? That if you have log of the same base on either side, you can drop those logs and just set the arguments equal to each other. So that's what I have here. These are both log. They don't have a base written there, so remember, common log is always base 10. So I can drop those and just set 8 equals 5 minus x. To get x all by itself, subtract 5. So then cancels out. Negative x equals 3. Divide by negative 1. So x equals negative 3. Here's what I mean by the check. Okay, so let me use a different color here. You just want to make sure that if you plug in this negative 3 into any argument for a log, that you get a positive value. So I don't have to worry about it over here. I know that I'm going to always be taking the log of 8. But over here, when I plug in this negative 3, then notice what happens. You have 5 minus negative 3, which ends up being 5 plus 3. So I will be taking the log of a positive value. So x equals negative 3 is our solution. Again, I always need to make sure when I'm solving a logarithmic equation, if your original problem had a log of an argument in it, you need to make sure that that argument stays positive with the x values that you arrive at. And if it doesn't stay positive, then you exclude that particular value. All right, I'm going to let you do number 4 and 5 because those should follow suit with either using a power or going from logarithmic to exponential form. Let's scoot on down then together and look at number 6. I'm not going to be doing number 7 because number 7 is exactly like number 2. So number 6 will actually take a little bit of room here on the page, so I'm going to bleed over into number 7 whenever I work it out. All right, so looking at number 6, I have 2 different bases here, so I can't just drop those bases, and I can't get these bases to be the same, so I'm going to have to use logarithms. You can use common log or natural log. I think I'll just use natural log here. So I take the natural log of the left-hand side equals the natural log of the right-hand side. Again, you could use common log if you wanted to. 3x plus 2. Erase that. Okay. All right, so now remember, by taking those logs, those natural logs, then that allowed these exponents to come down in front as coefficients. So now I have x minus 2 times the natural log of 5 equals 3x plus 2 times the natural log of 3. Now remember, the natural log of 5 and the natural log of 3 are just numbers. So those numbers then need to be distributed into that parenthesis. So that would be my next step. I'm going to go through and distribute. So that's going to look like this. X natural log of 5 minus 2 natural log of 5 equals 3x natural log of 3 plus 2 natural log of 3. Okay. Now from here, remember, your goal is to solve for x. So right now I've got x's on both sides, so I need to get my x's together and I need to get my numbers together. So this is going to take me a couple of steps here. I'm going to first bring that 3x natural log of 3 to the left-hand side, so minus 3x natural log of 3. So that looks now like x natural log of 5 minus 3x natural log of 3 minus 2 natural log of 5 equals the 2 natural log of 3, because this is canceling out. Now from here, I need to bring this 2 natural log of 5 to the other side, so I'm going to add it. So I'll be adding 2 natural log of 5 to both sides. That's going to get me here. So I have my x natural log of 5 equals, you already had the 2 natural log of 3, and then you added a 2 natural log of 5 to it. Okay. In any order over there that you want to have that in is fine. Now from here on the left-hand side, you notice that both of these terms have an x in common. You're trying to solve for x. Pull that x out, factor it out. Write what you have left over. So natural log of 5 minus 3 natural log of 3. And now lastly, this natural log of 5 minus 3 natural log of 3, all of that is just a number. So it's a number beside a letter. You always divide by the number beside your letter. So divide by the natural log of 5 minus the 3 natural log of 3. Cancels out. So I'm going to just box this in. This would be your exact answer. If you were putting this in your calculator, I'm going to do it all at one time, again, you would need one big parenthesis on the top divided by one big parenthesis on the bottom, and then still utilizing the parentheses that the natural log opens up for you in your calculator. And then that should give you an approximate value of negative 3.21. Excuse me. Okay. All right, so let's look at number 8 next. Okay, so in number 8, you have on the left-hand side 2 logarithms, but on the right-hand side you don't have a logarithm. You can't go directly now just because you have a logarithm on the left-hand side, not on the right-hand side. It has to be a single log on the left-hand side to be able to go from logarithmic to exponential form. These are both base 10 because you don't have a base down there, but you can't just go directly from that. We need to get this condensed down to a single log. So we did that in the last chapter, or in the last section, that this addition tells us that we can go to multiplication. So x times x plus 3 equals 1. Now you have one logarithm equaling the right-hand side, just a coefficient there. So this is base 10. Go now from logarithmic to exponential form. So base 10 raised to the right-hand side to the first power equals argument x times x plus 3. On the right-hand side, distribute. So that's going to give us x squared plus 3x equals 10. get x all by, or we want to solve for x, so let's pull that 10 over, subtract 10. So now I have x squared plus 3x minus 10 equals 0. Got a factor here, x and x, but this is a doable one. Most common way to multiply to give you 10, 5 times 2. You want a positive 3 in the center, so hopefully you agree then that 5 needs to be positive and 2 would be negative. Now you would set both of those equal to 0 and solve for x, so hopefully you would agree here that you would get x equals -5 and x equals a positive 2. We need to go back and check ourselves. Get a different color here so we can check ourselves. If you plug in -5 right here into this first argument, you would be trying at that point to take the log of a negative number. So automatically, -5 is not a solution. You still need to check the 2. Even though it's a positive value, you need to check that 2. So log of 2, that's a positive value, so that works. When you plug in 2 here, 2 plus 3 is a positive value, so that works. So x equals 2 is the solution. But like I said a minute ago, just because a value is positive doesn't necessarily mean it will be a solution. Say, for example, this had been a minus sign in between this x and the 3. If it had been x minus 3 and you plugged in a 2 there, 2 minus 3 is a -1, and then I'd be trying to take the log of a -1, and so that couldn't happen. So likewise, just because your value is positive doesn't mean it's a solution. Just because your value is negative doesn't mean it's not a solution. So it's always important you check every solution. Okay. Let's go on over and let's do number 9. In number 9, you might think, oh, well, all of these are natural logs. Can't I just drop these bases and that sort of thing? The only time you can drop those natural logs is if it's a single log equaling another single log. So I need a way to get rid of this addition sign, which, we can use that same technique that we did in the last problem, right? Because the natural log of the addition here means that I can write this as x plus 8 times x minus 5. And on the right hand side, to get rid of that 2 up here, the 2 can come up as an exponent. So that would equal the natural log of x squared. Now you have natural log of an argument equals natural log of an argument. That's when it's legal for you to drop the natural logs and set the arguments equal to each other. So over on the left hand side, I'm just going to go ahead and FOIL that out. And I would have x squared minus 5x plus 8x minus 40 equals, right hand side, x squared. Let's combine like terms. So x squared plus 3x minus 40 equals x squared. All right, let's get our x squareds together. Doesn't matter which x squared you take over, you'll notice on both sides it ends up canceling out, which is kind of nice because now we don't have to worry about having to factor. We just now have 3x minus 40 equals 0, so we can do a couple steps here and we'll have our x. Add 40 to both sides. So then that leaves us with 3x equals 40. Divide by 3. And so x equals 40/3. Now 40 divided by 3, I believe that's 13 1/3. Yes, 13.33. Again, don't just say, oh, it's positive, it's got to be my answer. Think about it up here. So if you were to put in 13, I know it's 13 1/3, but if you put 13 in for x, okay, 13 plus 8, that's going to give me a positive value. If we put in here 13 minus 5, that's going to give me a positive value. Natural log of 13, okay, all of that's going to be positive. So 40/3 is indeed my solution, okay? Number 10 is exactly like number 8, so I'm going to let you try that one. If you like, go ahead and stop the video now or try it later and check your answer on the solution key, but you should be able to do that one with what you've seen. Let's come on down and let's look at number 11. In number 11, you have 2 logarithms here on the left-hand side, and it is the same base, and it equals just a plain old number over here. So we can use a similar technique that we were doing in number 8. The only difference is that we have a minus sign this time, and so a minus sign, when you condense it down, turns into division. So you'd have 2x minus 1 over x minus 4 equals 2. Now I'm going to go from logarithmic to exponential form. Base 3 raised to the right-hand side, 2, equals the argument, 2x minus 1 over x minus 4. Of course, we know 3 squared is 9, equals the 2x minus 1 over x minus 4. We could just put a 1 underneath that one and cross multiply. So 1 times 2x minus 1, that'll give me 2x minus 1. 9 times x minus 4, distribute, so 9x minus 36. I like to take care of my x's, my letters next, so between 9x and 2x, 2x is smaller, so I subtract it from both sides. Negative 1 equals 7x minus 36. Add 36 to both sides. 7x equals 35, divide by 7, and so x equals 5. We go back up and check that 5 in, because we're saying that x equals 5. So make sure that when we plug 5 in, that we're going to get positive values here to take the log of. So 5 times 2 is 10, 10 minus 1 is 9, so that's a positive value. 5 minus 4 is 1, that's a positive value. So x equals 5 is our solution. All right, let's flip it over to the last page. Number 12, even though you've got a fraction there, once you look at the solution key, you're going to go from logarithmic to exponential form, and then I just showed you in the last problem how to cross multiply, so you should be good to go with number 12. I'm going to do 13, 14, and 15 with you. Okay. In number 13 and 14, I'm going to introduce a topic or a technique utilizing U substitution. Okay, so utilizing U substitution in number 13 and 14. In number 13, you see here that you've got your e raised to a negative power. Let's first start off by getting our exponents to be positive powers. So I would think of this then as, okay, I made that smaller. E to the x minus, well, if it's e to the negative x up top, then I can put e to the positive x on the bottom equals 1. And you might think, well, gosh, that made it worse because now I've got a fraction. Well, yes, in a way it did, but you know how to get rid of fractions. All right, multiply by common denominator. So e to the x times e to the x, e to the 2x, minus e to the x times this middle term will cancel out and just leave you with 6. E to the x times 1, e to the x. So now let's get that e to the x to the other side. So I'm going to subtract e to the x. So now this leaves me with e to the 2x minus e to the x minus 6 equals 0. Now from here, it's not perfect in looking like a quadratic, but hopefully you can kind of think about this. Oh, this kind of looks like an x squared minus x minus a number. That's kind of the idea of how I'm going to transform it using this U substitution. At this point, I'm going to establish a U value of U equaling e to the x. Okay, so if I let U equal e to the x, then this first one is, would you agree? Let me do this way. You have e to the 2x. Wouldn't you agree that that would be the same as e to the x squared? So that's why it's going to allow me to write this as u squared minus, well, we know e to the x, I told you that was u, minus 6. And the first time you see this u substitution, it might look a little strange to you, but this is a lot easier to factor and work with than e to the x's are, okay? Get a different color. So now from here, if I go to factor, the only way to multiply to give you u squared, u and u, most common way to multiply to give you 6, 3 times 2. Your goal is to get a negative 1 in the center, so you're going to make your 3 negative and your 2 positive. Now I'm going to set both of these terms equal to 0. So I'm going to get u equals positive 3 and u equals negative 2. You can't stop there. You were trying in the beginning to solve for x. So replace u. You know that u is e to the x, so replace your u's with, okay, e to the x equals 3, e to the x equals negative 2. Now solve for those x's. But this is a very straightforward solve for those x's, because how do you get rid of e? Just take the natural log of both sides, right? Natural log. So the natural log of e to the x, they just cancel out and just leaves you with x. So x is the natural log of 3. Take natural log over here. x equals the natural log of -2. Like we talked about in our previous video, you cannot take the natural log or the common log of a negative value, so that answer is automatically out, and you only have one solution, x equals +3. Box this off. Keep it separate. Okay. All right, number 14, you'll see me use that U substitution again. Okay. In number 14, the first thing I probably would do here is let's get rid of that fraction to begin with. So let's get rid of that 2. So I'm going to multiply everything by 2. The nice thing is on the left-hand side, the 2's cancel out and just leaves you with e to the x plus e to the negative x. And then over here, 3 times 2, of course, is 6. Now, from here, I can rewrite e to the negative x as 1 over e to the x, just like I did in the previous problem. I want to get rid of that e to the x in the denominator, so I'm going to multiply again by my common denominator. E to the x times e to the x, e to the 2x. E to the x times this 1 over e to the x is just 1, because those e to the x's cancel out. And then 6 times e to the x is 6 e to the x. I want to get it all on one side, so I'm going to subtract my 6 e to the x. So now that leaves me with e to the 2x minus 6 e to the x plus 1 equals 0. All right, so to get it a little bit more manageable, because I'm trying to solve for this x, so I don't have e's and x's here, I'm going to use the u substitution. I'm going to let u equal e to the x. So, with that said, if I do that, like I was showing you before, then can't you agree that e to the 2x is the same as e to the x squared? I'm just going to burn a step here in this one. Maybe this will help. Okay. So now, everywhere you see an e to the x, you're going to replace it with u. So, this would be u squared minus 6u plus 1 equals 0. Now, typically from here, we try to factor u and u. Only way to multiply to give you 1 and 1. And there's no way out of 1 and 1 you're going to be able to get a -6 here in the center. So, what that means then is I can't factor this. I'm going to have to use quadratic formula. So we say opposite b. So remember, this is your a, b, and c. So opposite b, so 6 plus or minus square root b squared, so -6 squared, minus 4 times a times c, all over 2a. So I have 6 plus or minus square root 36 minus 4 all over 2. Then that would give me 6 plus or minus the square root of, 32 over 2. Then I can think of, I want to break down that 32. So this 32 is the same as 16 times 2. I want to think about numbers that I can easily take the square root of, and I can take the square root of 16. Then that gives me 6 plus or minus the square root of 16 is 4, so it comes outside the house. 2 stays inside. Now at this point I can reduce, because these three values are, the three values all outside the house all have something in common. If they all three don't have something in common, you can't reduce any further. But in this case, 2, 4, and 6 all have a 2 in common, so I'm going to go through and divide everything by 2. So 2 divided by 2 is 1, 4 divided by 2, 6 divided by 2. So then that gives me 3 plus or minus 2 square root of 2 as an answer. Remember, that's your u value though. So u equals that. So, and remember that u is e to the x. So e to the x equals 3 plus 2 square root of 2. And e to the x equals 3 minus 2 square root of 2. To get x, just like I did in the last problem, you want to get rid of that e, so you take the natural log of both sides. So x equals the natural log of 3 plus 2 square root of 2. And x equals the natural log, because I would up here, let's write that. So natural log that cancels out, so base e, right? X equals the natural log of 3 minus 2 square root of 2. 3 plus 2 square root of 2 and 3 minus 2 square root of 2 are both positive values, so you can take the natural log of them. And when you do so, I'm going to double check myself, 3 plus 2. Yeah, one of them gives you positive 1.763 and the other one gives you negative 1.763. So your two values here, I'm just going to write it like this, plus or minus 1.763. I don't need to worry about checking my solutions here. I mean, you can make sure you got it right, but I'm not worried about, I don't have a logarithm to worry about, oh, these need to be positive or something like that. The bases or the arguments there don't need to stay positive. So those are my two values. All right, let's wrap it up here with the last problem over here on the right, number 15. In number 15, I'm going to try to, in this one, at least get myself down to having the same bases if I can. So 9, hopefully you recognize, oh, I can write 9 as 3 squared. So that would be 3 squared raised to the x minus 1 equals 100 times still 3 to the x. When you raise a power to a power, you multiply, so that would be 3 to the 2x minus 2 equals 100 times 3 to the x. Now, at least at this point, I do have a 3 on the left-hand side, and I've got a 3 raised to a power and a 3 raised to the power. So what I can do is if I divide by 3 to the x on both sides, on the right-hand side, it cancels out, so that's nice. On the left-hand side, since it's the same base, I can use my properties, and my properties say when I have the same base, the rule is then you can subtract your exponent. So you keep that base, and it's like saying, okay, the top minus the bottom equals 100. And then I can clean that up, and okay, I have 3 to the x minus 2, just cleaning it up, equals 100. Now you can take common log or natural log. I'm going to take common log this time. You'll hopefully recognize why I'm doing that. Mainly because over here on the right hand side I have a 100, and I know that common log is base 10, and I can write 10 to a power and get 100. So if I take the log of both sides, it would look like this. The log of 3 to the x minus 2 equals the log of 100. Now remember that exponents come down in front as coefficients, so I would have x minus 2 log of 3 equals, on the right hand side, we know this is common log, it's automatically base 10. Can I write 100 as 10 to the second power? And in doing so, the log over here completely goes away, right? Because 10 base and argument match up, and it's just going to leave me with my exponent. It's just going to equal 2. It would be legal here if you want to, on the left-hand side, distribute, but I'm not, just because if I do, I'm going to have more logs in my final answer, but you certainly can. It would be perfectly legal if you wanted to. At this point, your goal is to solve for x, so log of 3 is just a number. Just divide by that log of 3. Cancels out over here, so x minus 2 equals 2 divided by the log of 3. And then lastly, to get that x all by itself, add 2 to both sides. So cancels out over here, x equals 2 divided by the log of 3 plus 2. Final answer. Again, I don't have to worry about checking it because my original problem did not have log of an argument in it. So that would be my final answer. Now, if you chose to distribute through, you might have a little bit of a different answer here in this form. You probably can reduce it down to get that. The approximate answer here would be 6.19. Okay, so there's your exact and your approximate solution. All right, guys, let me know if you need any help. Thanks a lot. And remember, I have the Collaborate sessions.